Hi all, this is a short video with my solution to this problem. Wording asks us about calculating the optimum use of utilities while using the current minimum approach. Then this is looking first for this minimum approach and then proceeding to an analysis, and finishing by choosing the right utilities among this heating and cooling. This is mainly a problem on data extraction. Calculating the minimum approach is a question of knowing the temperatures at the entrance and the outlet of any heat exchanger. And we know almost every one, except this at the outlet of the heater, and also we don't know the duty of the heat exchanger. Okay, extrapolating the MCP, the thermal inertia of this stream that we know, and across this heat exchanger give us the temperature at the outlet. And with this temperature known and the final temperature of the oxygen stream, we can calculate the duty of heat exchanger number 4. Then is a question of crossing the right streams and looking at the approaches. Minimum approach is 10 Kelvin and appears 2 times here and here. And now data extraction. We're gonna start with the only hot process stream, the air feed, that start at 350. This change in temperature doesn't concern us. Then for 350 Kelvin, it crosses heat exchanger 1 with the duty, the cooler, the heat exchanger 2, 3, it leaves some heat at the reboiler, and finally is expanded to form the top entrance to the column. All this cooling duty are the need of the feed. You can find the total figure here. Then a cold stream, that is the vaporization duty in the column. This is the heat that takes the liquid at the bottom to produce the vapor up the column. And it is the summation of this cooling duty for the feed and the ambient air that hits the same liquid. You have this summation and here the total figure. A second cold stream is this heating of the oxygen liquid product of bottoms. The third one is the head that takes the heat exchanger 3 and 4 to arrive to the final temperature. These are the both duties and the final figure. And finally, this vapor taken at the bottoms that pass through heat exchanger 2 is further heated and then cooled to the 350 final Kelvin. Then the needs of this stream is the duty of 2 plus the duty of the heater minus the duty of 4. You have the final figure here. Now we can complete the problem table with temperatures and duty and proceed in Higgs to the analysis with this minus 10 Kelvin. You get a threshold problem that just needs heating, not cooling. Most of the heating can be supplied with cheap ambient air, but there is a small need at high temperature here. So we will need a small amount, just 500 watts or kilowatts of saturated steam that has temperature enough to do the job, and the rest is done with ambient air. And this is all. This is the cheapest set of utilities.